Welcome back to the deep dive. Today, we're embarking on a really mind-bending journey. It might completely reframe how you think about numbers, and maybe even about reality itself.
That's right.
Think about it. What if the numbers you learned in school, the simple 1, 2, 3s, maybe even complex numbers if you went further, what if they're just the surface?
Just scratching the surface of something vast.
Exactly. What if math isn't something we invent to describe the universe, but something the universe itself is actually made of?
That's the big question, isn't it?
It is. So today we're taking a deep dive into some truly profound concepts. They come from Philip Randolph Adam Lilien's work, Hypercomplex Coherence, the Ontological Necessity of Numbers. Our mission, our goal here, is to explore this radical idea, almost audacious really, that numbers aren't just abstract tools or convenient labels, things humans made up.
Right. Not just labels.
Lilien says they are ontological necessities, the inherent, unavoidable operators that dictate how reality's coherence, its order, its structure, and its very dimensionality emerge.
And how they maintain themselves.
Yeah. It's a fundamental shift in how we might understand existence. It's huge.
And it's really not just some, niche mathematical curiosity, not just a clever game for specialists tucked away in university departments. Lilien's framework suggests something much, much deeper, that the structure of these numbers, these hypercomplex numbers we'll get into, directly maps to, maybe even dictates, the most profound symmetries and forces governing our universe.
Wow.
Yeah. And the really fascinating part, for me anyway, is how this perspective just fundamentally challenges centuries of thinking, both philosophical and scientific, about what mathematics is.
How so?
Well, it moves us away from seeing math as just a language we develop, to describe reality. Instead, it asks us to see it as the inherent blueprint, the actual foundational grammar that reality itself is built from.
The grammar of reality. I like that.
Exactly. It forces us to consider that these mathematical structures, they have to exist in a certain way for our universe to be coherent, for it to work the way it does.
Okay, let's unpack that core idea then. Because ontological necessity, it sounds incredibly profound, almost like a philosophical claim more than a scientific one.
It straddles that line, definitely.
We usually think of numbers as tools, right? 3 helps us count things. 2 plus 2 equals 4 is a logical step. But you're saying, or Lilien is saying, they're much more than that.
Much more.
So what does it really mean for numbers to be an ontological necessity and not just, abstract inventions we came up with?
It's a critical distinction, really vital. When we talk about ontological necessity, we're saying something must exist or it must be structured in a particular way for reality to be. Well, reality, to be consistent, intelligible. It's not a choice we made. It's not an arbitrary invention. It's a foundational requirement for things to be.
Okay.
Think about it like this. Traditional mathematics, what Lilien calls the orthodox view, often treats these more complex number systems like quaternions, octonions, the ones we'll discuss, as kind of exotic inventions.
Right, things mathematicians cooked up. Useful, maybe, but...
Exactly. Useful, clever extensions of our algebraic toolkit, sure. But not necessarily fundamental to reality itself, just good descriptions.
But Lilien flips that.
Completely flips it. His ontological mathematics argues these numbers are necessities. They aren't just useful, they are essential. They are inherent properties of existence itself.
Can you give an analogy, maybe?
Sure. Think about a bridge designer. They use mathematical equations, right, to calculate stress, strain, load-bearing capacity. Those equations are tools.
Okay, yeah.
But the underlying principles, gravity, the way steel behaves under tension, the laws of physics, the fact that iron must behave a certain way under stress, those are ontological necessities for the bridge to even stand up.
I see. The laws are necessary, the equations just describe them.
Precisely. Lilien argues that numbers themselves are more like those underlying principles, like gravity or material science, not just the equations we use to describe them. They are the necessity.
That's a fantastic analogy. Really clears it up. So these numbers aren't just descriptive, they're prescriptive. They are the rules the universe runs on.
That's the core idea.
And a huge part of this framework seems to rely on 2 key concepts: coherence and resonance. Can you elaborate on those, especially coherence, since it's right there in the title of the work?
Absolutely. Coherence, in this context, it refers to the underlying order, the intrinsic consistency, the deep, often hidden interconnectedness that's woven into the very fabric of reality.
How things hang together.
Exactly. It's about how everything fits, how it works together, not randomly, but in a meaningful, structured, harmonious way.
Yeah.
Without coherence, reality would just be chaos, a jumble. It's the fundamental intelligibility of existence.
Makes sense. And resonance.
Resonance, then, describes how these coherent structures interact, how they sort of vibrate or respond to each other, and ultimately how they manifest into the physical phenomena we actually observe.
Okay.
Imagine it maybe like a complex symphony. Coherence is the underlying musical score, the intrinsic harmony, the structure, the rules of counterpoint. Resonance is the actual sound waves, the vibrations in the air, the way the different instruments interact to bring that score to life.
Ah, I like that.
It shapes everything, from the fundamental forces binding particles together all the way up to the emergence of vast cosmic structures and dimensions. It's the dynamic expression of that underlying coherence.
So reality is this incredibly intricate tapestry, and numbers are the threads providing the consistent pattern. And Lilien introduces this brilliant concept, the coherence ladder. What's that about? How does it help us understand this unfolding structure?
The coherence ladder is Lillien's way of visualizing this progression. It proposes a series of number systems, each getting progressively more sophisticated. And each step up this ladder represents or encodes a specific, increasingly complex type of coherence and resonance.
But it's like climbing rungs of complexity.
Exactly. But it's crucial to understand it's not just presented as a historical timeline of human mathematical discovery. It's presented as a conceptual map, marking the inevitable way reality itself must unfold into, as Lilien puts it, deeper and richer dimensionality.
So each step is an ontological requirement, a necessary stage for the next level of structured existence to emerge.
Precisely. Each number system unlocks, or perhaps is, a new layer of coherence needed for reality to become more complex.
Okay, that makes perfect sense. Now, before we jump into the really hyper-complex stuff, the mind-bending numbers, maybe we should ground ourselves on the first few rungs, the ones we're all familiar with, real numbers and complex numbers. How does this ontological framework view these simpler systems?
That's a really good place to start. Real numbers, your basic counting numbers, integers, fractions, decimals, even irrationals like pi, they form the very first rung of this ladder.
The foundation.
Absolutely. Lilien refers to them as encoding coherence depth. They establish the most fundamental idea of how much, or how far, or how big along a single line, a single dimension. They provide the basic quantitative coherence, the ability to measure, to compare magnitudes in a linear way. Without real numbers, we couldn't even grasp the concept of one thing versus two things, or measure a distance. They're the bedrock.
Right. Seems pretty fundamental. Ontologically necessary, you could say.
Definitely. Now, the next rung up gets a bit more interesting. Complex numbers. Usually written as a plus pi, where is that famous imaginary unit, the square root of -1.
The bane of many high school math students.
Yes, perhaps. But historically seen mainly as a mathematical abstraction, a clever trick to solve certain equations. Here, though, they represent a crucial ontological leap.
How so?
They introduce what the source calls orthogonal resonance, or the first resonance plane. What does that actually mean? Well, real numbers let us move back and forth along a line.
One dimension.
Right. Complex numbers, by introducing this this imaginary unit, allow us to move orthogonally. That means at a right angle to that original line. This immediately opens up a plane, a two-dimensional space.
From a line to a plane. Okay.
And this orthogonal resonance is vital. It's the mathematical underpinning for anything that exhibits simple, cyclical behavior. Oscillations, waves, rotations that are confined to a plane. Think of a pendulum swinging back and forth, or an alternating electric current switching direction, or the simple harmonic motion of a plucked guitar string. Complex numbers don't just describe these things conveniently. The argument is they are the inherent mathematical structure that allows for that kind of consistent two-dimensional oscillatory coherence to exist in the first place.
Wow. So they were the inevitable mathematical lift needed once reality had to organize periodic motion, things happening in 2D.
That's the idea. A necessary step up the coherence ladder.
That's a really powerful reframing. So these aren't just historical discoveries mathematicians stumbled upon. They're inherent necessities. First for basic quantity, then for 2D cyclical resonance. But then, as you said, things get really interesting. We climb this coherence ladder further, and we move beyond 2 dimensions. And this is where we start hitting structures that really challenge our everyday intuition.
Absolutely. We leave the familiar plane behind.
So the next step up brings us to quaternions. Now, these were a huge deal, right? Developed by the Irish mathematician William Rowan Hamilton back in the 19th century. Wasn't there a famous story about him carving the formula onto a bridge?
That's the legend, yes. Brougham Bridge in Dublin. He supposedly had this flash of insight while walking and, lacking paper, etched the fundamental formula right onto the stone. Whether strictly true or not, it highlights the breakthrough moment.
So what makes quaternions so special? How do they fit onto this ladder of increasing coherence?
Quaternions are definitely a pivotal step. They extend beyond the two dimensions of complex numbers. They introduce not one, but three distinct imaginary units.
Three, not just I.
Right. Formally, a quaternion Q is written as Q plus bi plus Cj plus dk. Here, A, B, C, and D are just regular real numbers, but I, J, and K are these new imaginary units. Their fundamental properties are defined by the rules. I losses tot such as -1. And crucially, co-1. That last relation, -1, is really elegant and sort of locks their structure together.
Okay, three imaginary dimensions plus one real one. Four components total.
Exactly. But the truly critical thing, the defining characteristic that makes them so profound for this discussion, is that their multiplication is non-commutative.
Non-commutative. Okay, break that down. What does that mean practically?
It means the order you multiply them in matters. It's a radical departure from the arithmetic we learn in school. With real numbers, or even complex numbers, 2, 3 is always the same as 3, 2. The order doesn't change the result.
Right, commutative property.
But with quaternions, order is crucial. I multiplied by j, written ij, is not the same as j multiplied by I. In fact, ijk, but g idoi k. They give different results, often the negative of each other.
Whoa, okay, that's weird. Why is that so important for the universe's structure? Can you give a tangible example?
Absolutely, and this is where it gets fascinating. This non-commutative property isn't just some abstract mathematical quirk. Lilien argues it directly reflects the fact that rotations in 3D do not commute.
Rotations in 3D space, like turning an object.
Exactly. You can demonstrate this yourself very easily. Grab any object that isn't symmetrical, like a book or your phone. Hold it in front of you.
Okay.
Now, rotate it 90 degrees forward around its horizontal axis, let's call that the x-axis, then rotate it 90 degrees sideways around the vertical axis, the y-axis. Note the final orientation.
Got it.
Now, put the object back how it started. This time, reverse the order. Rotate it 90 degrees sideways, y-axis first, and then 90 degrees forward, x-axis.
Ah, it's in a different position, a completely different orientation.
Right. The final orientation depends entirely on the order in which you perform the rotations. That's non-commutativity in the physical world.
That's incredible. I never thought about that simple fact reflecting deep mathematics.
And that's the key insight. It means quaternions aren't just some clever algebraic trick Hamilton dreamed up. They embody this fundamental, unavoidable, non-commutative property of three-dimensional space itself. They capture the very essence of how things move and orient themselves in the world we live in.
So they're not just describing 3D rotations, it's like they are the mathematical structure that makes coherent 3D rotations possible, like the built-in instruction set.
That's precisely Lilien's ontological perspective. As the source puts it, quaternions encode the coherence of orientation. They are the resonance operators of 3D space.
Resonance operators of 3D space. Okay.
Meaning, they don't just describe how things turn, they are the mathematical essence, the structure, that allows orientation and rotation to maintain coherence, to be consistent and predictable within our 3D world. They were, in Lilien's view, an inevitable coherence lift once dimensionality required spatial resonance, a necessary mathematical expansion for 3D reality to function coherently at all.
Wow. And this connects to actual physics, right?
Profoundly. In physics, quaternions are incredibly useful. They naturally describe rotations, obviously, but also things like spin and angular momentum.
Particle spin, like electrons.
Exactly. Spin is a fundamental intrinsic property of quantum particles like electrons. It's a form of angular momentum they just have, not because they're physically spinning like a top, but as an inherent quantum mechanical attribute. It's weird.
Definitely weird.
And quaternions offer an incredibly elegant and efficient mathematical language to model spin and angular momentum, often much simpler and more intuitive than using cumbersome matrices, which is another way to do it. They are, you could argue, the exact mathematical language required for these fundamental aspects of 3D reality.
That's amazing. So these numbers quaternions, they aren't just for pure mathematicians solving abstract puzzles. They're the inevitable mathematical framework our universe sort of deployed to organize movement, orientation, and even fundamental particle properties in 3 dimensions.
Deployed, or perhaps they are the organization.
Right. They're like the universe's own internal operating code for how things turn and interact spatially. And if quaternions didn't exist as an ontological necessity, it implies 3D rotations would, what? Fundamentally chaotic. Impossible.
Or at least reality wouldn't have the coherent structure we observe in 3D. It points to their necessity for the world as we know it.
Okay, so if the non-commutativity of quaternions unlocks the secret to coherent 3D rotations, what happens when reality needs even richer structure, when dimensionality gets even more complex?
We climb higher on the coherence ladder.
We move beyond mere non-commutativity, and this brings us to the next level, octonions. Now, this name itself sounds like it's taking us firmly into the realm of the truly exotic.
It definitely feels that way.
Yeah.
Octonions represent another significant jump in mathematical complexity. And from this ontological viewpoint, they represent a higher form of coherence, moving into what Lilien calls hyperdimensional resonance.
Hyperdimensional resonance. Okay, so what are they?
They are an 8-dimensional algebra. So instead of one imaginary unit like complex numbers or 3 like quaternions, octonions have 7 distinct imaginary units plus the real component. 8 dimensions in total.
7 imaginary units. Wow.
Yeah. But the truly key property here, the dramatic departure from everything before, is that octonion multiplication is not only non-commutative, order still matters, but it's also non-associative.
Okay, wait. Non-commutative meant AB isn't BA. What does non-associative mean in practice? How does that work?
It means that the way you group multiplications changes the answer. So if you have 3 octonions, say A, B, and C, performing the multiplication, A, B, C, where you multiply A and B first, then multiply the result by C will generally give you a different result than A, B, C, where you multiply B and C first, then multiply A by that result.
So the parentheses actually matter now. ABC, ABC.
Exactly. The grouping changes the outcome. This is a profound shift. It takes us even further away from our standard arithmetic rules where grouping makes no difference. It signifies a much deeper, more intricate level of internal structure and interaction within these numbers.
It sounds like a coherence that doesn't follow simple step-by-step logic.
That's how Lilien puts it. A coherence that exceeds linear logic, where simple sequential operations aren't enough anymore to define the relationships. It's a more holistic, interconnected structure.
How are these viewed traditionally in math? Still useful or just weird?
Historically, the orthodox view in mathematics has often seen octonions largely as an exotic curiosity, a strange, albeit beautiful, algebraic structure, but one without obvious widespread applications like complex numbers have in engineering, for instance. Kind of isolated.
A mathematical outlier.
Something like that. Yeah. But the ontological view, the one Lilien champions, sees them very differently. It considers them a higher coherent structure where resonance exceeds linear logic.
Meaning they are necessary.
Necessary, yes, to describe a kind of underlying order in reality that simply cannot be captured by simpler, more linear mathematical frameworks like reals, complex numbers, or even quaternions. Their non-associativity isn't a flaw or a weird quirk, it's a feature. It reflects a fundamental property of how reality coheres at an even deeper, more complex level than 3D rotations.
And incredibly, these aren't just theoretical constructs. They actually pop up in some really advanced areas of physics, don't they?
Their appearance in cutting-edge theoretical physics is truly remarkable. It's perhaps the strongest hint towards their potential ontological necessity. Octonions appear in places like string theory.
String theory, okay. Which postulates extra dimensions.
Exactly. String theory needs more than our familiar 3 spatial dimensions to work mathematically, often requiring 10 or 11 dimensions in total. Octonions seem to naturally fit into the mathematical structures needed to describe these higher dimensional spaces.
And also something called exceptional Lie groups.
Yes. Specifically, the exceptional Lie groups, known as EAA, E's, and E.
Okay, exceptional Lie groups. That sounds incredibly complex. Can you give us a quick, accessible sense of what a Lie group is and why these exceptional ones are important? Keep it simple.
Okay, let's try. Think of Lie groups as mathematical tools, very sophisticated ones, for classifying symmetries. Specifically, continuous symmetries, things you can do smoothly, like rotating a sphere without changing its fundamental nature.
Like rotations and sliding things around.
Exactly. Those familiar symmetries are described by relatively simple Lie groups. Now, mathematicians have classified all possible simple Lie groups. Most fall into neat families. But then there are these 5 outliers, these exceptional Lie groups, GF, E, euro, E, ear. They don't fit the standard patterns. E, ear, and ear are the largest and most complex of these.
So they represent really complex, rare kinds of symmetry.
Extremely complex, yes. And their appearance in theoretical physics, particularly in string theory and ideas trying to go beyond our current standard model of particle physics, hints at symmetries in nature that are so profound, so intricate, they might govern dimensions or interactions far beyond what we can currently observe or even imagine.
And octonions are linked to these.
Intrinsically linked, the very structure of these exceptional groups, especially EA, seems to be deeply connected to the non-associative algebra of the octonions. This suggests octonions might be foundational to these incredibly deep, hidden symmetries of reality. Lilien's source even speculates, could the hidden symmetries of the fundamental forces ultimately be rooted in octonionic coherence frames? Are octonions the mathematical grammar needed for a truly unified theory of physics, one that incorporates these exceptional symmetries?
That's a huge question.
It is. Ontologically, then, octonions represent coherence where dimensionality outruns ordinary reduction hyperfractal resonance operators.
Hyperfractal, what's that imply?
It suggests structures and relationships of immense complexity. Maybe self-similar patterns across different scales like regular fractals, but operating in ways far beyond our intuition for simple dimensions. Think of patterns within patterns, relationships within relationships, unfolding endlessly, but in a way that's profoundly ordered and coherent, not random. It hints at a reality that is far richer, far more intricate than what we perceive directly. A reality demanding a more sophisticated mathematical language like octonions to describe its underlying order and its incredibly complex, non-associative resonance.
It's just incredible to contemplate that these octonions aren't just abstract math puzzles, but potentially the actual mathematical language for reality's deepest yet to be found secrets, operating in dimensions or forms of coherence way beyond our experience, but actively shaping the universe.
Shaping it in ways we're only just beginning to glimpse mathematically through things like string theory and these exceptional symmetries.
It's like the universe has this incredibly complex, non-associative source code running deep within its fabric. Unbelievable. Okay. So we've climbed from reals to complex numbers, then the non-commutative world of quaternions, and now the non-associative realm of octonions, each step revealing deeper, stranger coherence. From these specific dimensional structures and increasingly complex rules, we now arrive at what Lilien calls the universal coherence framework. This brings us to Clifford algebras, also called geometric algebras. This sounds like the final boss, the ultimate unifying language.
In a way, yes, Clifford algebras or geometric algebras represent a monumental unifying concept within this ontological framework. What makes them so incredibly powerful is that they manage to unify scalars, vectors, bivectors, and higher multivectors into one single structure.
All of them. Scalars, vectors, what are bivectors and multivectors again?
Let's break it down, because understanding the components shows why Clifford algebras are so comprehensive. They bring together scalars. These are just your basic numbers, magnitudes without direction, like the number 5. In Lilien's framework, remember, they represent coherence depth, just how much. Vectors, we know these, magnitude and direction, like velocity or force. The source connects these to directional resonance, how things move or push in a specific direction within a coherent field. Bivectors, these are a bit more abstract but crucial. While a vector is like an arrow pointing in a direction, a bivector represents an oriented piece of a plane. Think of it like a small, flat area that also knows which way it's spinning, essentially. They capture rotation.
Ah, like the rotational aspect of quaternions.
Exactly. The source links bivectors to rotational coherence, but in a more generalized way than just quaternions for 3D. Bivectors handle rotations in oriented areas beautifully, and they work in any number of dimensions, trivectors and beyond. Going further, trivectors represent oriented volumes, like a small cube that knows its orientation in space. And higher multivectors represent hypervolumes in dimensions beyond 3. These encode volume and hypervolume resonance.
So they describe how space itself, in all its dimensions, coheres and resonates.
Precisely. They capture the coherence of dimensionality itself. So Clifford algebra bundles all of these magnitude, direction-oriented area rotation, oriented volume, and so on into one elegant, unified mathematical system.
That sounds incredibly useful for physics, having one language for all that geometry.
It is immensely powerful. This unification makes Clifford algebra arguably the natural language for many fundamental areas of physics. Lilien states they provide the natural language for spinors, quantum mechanics, and gauge fields.
Okay, spinors, quantum mechanics, gauge fields. Let's unpack that link.
Right, spinors. These are really fundamental mathematical objects describing that intrinsic angular momentum of quantum particles, like electrons. They're actually more fundamental representations of spin or orientation than simple vectors are.
More fundamental how?
Well, a vector returns to its original state after a 360-degree rotation. A spinor, bizarrely, needs a 720-degree rotation to get back to where it started. Clifford algebras provide a very natural and elegant home for spinors, revealing their geometric meaning. quantum mechanics. The whole mathematical framework of quantum mechanics, governing the subatomic world with its probabilities and wave-particle duality, finds a powerful unified description within Clifford algebras. Many complex quantum equations become simpler, and their geometric meaning clearer. Gauge fields. These are the mathematical structures physicists use to describe the fundamental forces, electromagnetism, the strong and weak nuclear forces. Clifford algebras offer a unified way to handle the geometry underlying these force fields, potentially revealing deeper connections between them.
So it streamlines the math of fundamental physics.
It really does.
Mhm.
It suggests that these seemingly different aspects of physics, geometry, spin, forces might all stem from the same underlying coherent mathematical structure, which is expressed by Clifford algebra. So each component within a Clifford algebra encodes a specific field of coherence, as we discussed. Scalars for depth, vectors for direction, bivectors for rotation, trivectors for volume. They don't just contain these different types. They are the coherent mathematical expression of how these different forms of resonance exist and interact dynamically.
They show how all these layers of coherence are woven together.
Exactly. Interwoven into a single structure.
This really does sound like the ultimate blueprint. What then is the grand ontological purpose Lilien assigns to Clifford algebras?
The grand ontological purpose is, well, truly cosmic in scope. The source states, ontologically, Clifford algebras are the cosmic architecture of coherence, providing the scaffolding for field interactions and dimensional emergence.
The cosmic architecture, the scaffolding.
Yeah. It positions them as the fundamental blueprint, the underlying structure upon which all field interactions, all the forces we see, and the very emergence and organization of dimensions are built and maintained coherently. They provide the total coherence scaffolding, where, importantly, all reductions are embedded.
What does all reductions are embedded mean here?
It means that the simpler number systems we've discussed, reals, complex numbers, quaternions, even octonions to some extent, aren't just separate islands. They are naturally contained within the larger, more comprehensive structure of Clifford algebras.
Like Russian nesting dolls.
That's a perfect analogy. Each simpler system is a necessary, perfectly fitting substructure within the grand design of Clifford algebras. They all contribute to the universe's overall coherence, but Clifford algebra is the framework that holds them all together, ensuring they function as a unified whole. It's the overarching mathematical structure.
That is a staggering concept. Truly staggering. To imagine the entire universe, from the tiniest particle vibration to the largest galactic structures, as this incredibly complex yet perfectly coherent structure. And Clifford algebras are the complete architectural plans.
Master blueprint.
Detailing not just how every part fits, but how it interacts, how forces work, how dimensions emerge, all in perfect, inherent coherence. It's like finding the universe's ultimate operating system, constantly running, ensuring everything stays consistent.
That's the vision, yes.
Okay. So we've journeyed from the familiar reals through complex numbers, the non-commutative quaternions, the non-associative octonions, and now the unifying Clifford algebras. What's the overarching message here? What is Lilien ultimately saying about the indispensable place of these hypercomplex numbers?
The central thesis, the really profound takeaway from this whole journey, is Lillien's core argument. Each hypercomplex extension is not arbitrary invention, but an ontological inevitability.
Not invented, but inevitable. Discovered, not created.
Exactly. It wasn't just mathematicians being clever. These number systems had to exist in our mathematical landscape because they reflect the indispensable inherent structure of reality itself.
Let's quickly recap that coherence ladder then, seeing that inevitability.
Good idea. Reals provided the essential coherence depth, basic magnitude, necessary for even quantifying existence. Complex numbers opened up orthogonal resonance, the first bivector plane, necessary for 2D cycles, waves. Quaternions gave us spatial resonance, encoding 3D rotations, orientation coherence, necessary once reality needed consistent 3D movement. Octonions pushed into hyperdimensional resonance, reflecting exceptional symmetries, non-associative coherence, necessary perhaps for the deeper structure of forces and dimensions. Clifford algebras, the total coherence scaffolding, integrating all previous forms, embedding all reductions, the necessary framework for unifying geometry, spin, fields.
Each step required for the next level of reality's complexity.
That's the claim, and the source emphasizes this ultimate conclusion. Thus, the expansion of number is the map of coherence emergence.
Wow. So the history of discovering these numbers isn't just human history.
It's a revelation, a map of how coherence itself has unfolded, necessarily, step by step, into deeper and richer dimensionality within reality itself. Our mathematical discoveries are just us catching up intellectually to the universe's inherent, unavoidable structure. We're finding what must be there.
This completely challenges how we see numbers, not as static symbols, not just tools for counting or calculating, but as dynamic operators, active blueprints, actually shaping the fabric of existence.
Shaping or perhaps being the fabric.
Right. It's like the universe isn't just described by math, it fundamentally is math, constantly, calculating itself into being through these structures, each number system a necessary stage of its coherent unfolding.
It transforms mathematics from a purely human invention into something much more fundamental, maybe the language the cosmos speaks to itself.
So thinking about physics, what does this all mean for our understanding of the fundamental laws? How does it change how we view reality if these numbers are ontological necessities, not just useful descriptions?
Well, Lilien's framework doesn't just stay philosophical. It draws very specific, concrete lines connecting these mathematical structures to actual physical phenomena we observe and struggle to explain. These connections are presented as evidence for this ontological necessity.
Like what specifically?
For instance, consider some really weird quantum stuff. Spin and entanglement reflect complex and quaternionic bivectors.
Spin, we talked about that intrinsic angular momentum, and entanglement, that spooky action at a distance.
Exactly. That bizarre quantum link where two particles act as one, instantly influencing each other regardless of distance. It defies classical intuition completely. This perspective suggests that the mathematical essence of these deeply counterintuitive quantum phenomena finds its natural description and maybe its ontological root in the properties of bivectors, which are naturally handled by complex and quaternionic structures.
So the way particles inherently twist and link is actually encoded in these number systems as a necessity.
That's the implication. The mathematics isn't just describing it well. The mathematics is the reason it behaves that way.
Okay, what else?
Moving up the ladder again. Gauge symmetries may be tied to octonionic coherence frames. Now, gauge symmetries are absolutely central to our best theory of particle physics, the Standard Model. They're the deep principles dictating how the fundamental forces, electromagnetism, the nuclear forces actually work, how they transmit their effects.
Right, very fundamental.
This suggests that the intricate, non-associative coherence described by octonions might not just be a feature of obscure theories like string theory. It might be the mathematical bedrock from which these fundamental forces, the ones holding our atoms and universe together, actually arise. The deep, hidden symmetries governing all interactions could be fundamentally octonionic in their nature.
But the rules of forces require octonions to exist.
That's the provocative idea. And then, bringing it all together. Clifford algebras provide the mathematical backbone of coherence unification, integrating geometry, spin, and fields into one coherent structure.
The grand unification picture.
Exactly. This is the vision offered by the framework, that all these diverse pieces of physics, the geometry of space-time, the quantum spin of particles, the force fields mediating interactions aren't separate things coincidentally described by math. They can all be understood within a single, powerful, coherent mathematical language. Clifford algebra. It offers a potential pathway to seeing how all these elements emerge and interact as aspects of one single, consistent reality. It's perhaps the most promising candidate we have for the mathematical language of a theory of everything, precisely because it seems to be the universe's own native tongue for expressing coherence.
This leads to that philosophical shift you mentioned.
It really does, because if this is right, then the history of number is the unfolding of coherence itself. It completely flips the script.
How so?
It's not. Humans invented math, then noticed, wow, some of it surprisingly fits the world really well. The universe is structured mathematically, fundamentally. Our discovery of numbers is just as slowly, piece by piece, peeling back the layers of that inherent reality. So what mathematicians often saw as exotic inventions are revealed as ontological necessities. They aren't optional extras. They are unavoidable features of existence itself. Our whole pursuit of mathematical understanding becomes a journey into the deepest truths of the cosmos.
Wow. This isn't just for the theorists, then. This is a completely different way for anyone listening to perceive the ground rules of their own existence. What if the universe isn't just following rules, but is the embodiment of those mathematical rules?
That's the implication.
Constantly calculating itself into being through these hypercomplex number systems, each one representing a necessary stage of coherence, of dimensionality. It makes you look at, well, everything differently, every number, every equation, every physical interaction, every spin, every rotation, with a totally new sense of awe and profound inevitability.
It's like seeing the hidden code, the source code, running underneath everything we experience.
What a journey indeed. We've gone from the basic coherence depth of real numbers through the orthogonal resonance of complex numbers for oscillations, the spatial resonance operators of quaternions defining 3D rotation, the hyperdimensional resonance of octonions hinting at deeper symmetries, all the way to Clifford algebras as the total coherent scaffolding for everything. We've seen how each number system seems to act not just as a description, but as a fundamental operator of coherence, an unavoidable necessity for reality as we know it.
That's it in a nutshell.
So just to hammer home the core message from Lilien's work, numbers are not passive tools, not just human inventions. They are the active blueprints, the very operators of coherence emergence, intrinsic to reality, dictating its structure, its possibility.
And that really is the powerful, indelible takeaway from this deep dive today. As Lilien emphasizes, each extension, real, complex, quaternionic, octonionic, Clifford, is not optional but necessary, marking the way coherence unfolds into deeper and richer dimensionality. Thinking this way profoundly shifts how we might approach the search for a unified theory of everything, doesn't it?
Oh, so.
It suggests the quest isn't just about finding the right equations that happen to describe reality well. It's about understanding the fundamental mathematical structures that must exist for reality to cohere at all. For it to even be possible, we're searching for the universe's pre-existing mathematical grammar, not just writing a good story about it.
That leads to a final, really provocative thought for you, our listener, to chew on. If these hyper-complex numbers, quaternions, octonions, Clifford algebras, are indeed fundamental, these ontological necessities, what other mathematical structures, what other ontological necessities might still be out there waiting to be discovered in the vast realm of mathematics?
A tantalizing question.
And what new, perhaps unimaginable layers of coherence and dimensionality might they unlock for us, both in our scientific theories and maybe, just maybe, in our direct perception of reality someday? How might understanding these deeper numerical blueprints change how you see the world day to day, how you perceive the intricate inherent order all around you?
It certainly gives you a new lens to look through.
Keep exploring, keep questioning, and maybe, just maybe, look at the numbers and the patterns around you with a renewed sense of wonder. Because as we've explored today, they might be infinitely more than you ever imagined. They might just be the very fabric of existence itself.